Well, we're super excited to be here today. Kathleen and I have partnered on many different things surrounding AI, and we're super excited today to be talking to you about large language models. So just a couple of the objectives that we're going to go over today. I can't sit any longer. We're going to talk about some principles of AI, look at identifying problems that can be created by AI. How many of you remember when we implemented electronic medical records and everyone thought that it was going to solve everything? I remember getting, probably some of your teams do this as well, they get information on bad things that have happened in the hospital. One day, a thing came across my desk that said, it's the problem of the EMR, and what the problem was is the nurse had put a narcotic syringe in her pocket. So just like, just like the EMR can't fix stupid sometimes, AI, that was humorous. I love nurses. I'm a nurse. We're all nurses. Bonded together. But anyway, AI can't fix everything, and it will have some problems. We're also going to be looking at new opportunities in nursing. I think this is a very exciting time to be a nurse and to use our expertise in a different way and not advocate that to another discipline. And lastly, we're going to be talking about evaluating our readiness for implementing AI and just our readiness for ourselves to be able to utilize AI and speak to that topic. So if you haven't already, someone on the front row told me it was taking them 44 minutes. Is it still cycling?
I turned off the Wi-Fi, it works fine.
Okay. Turn the Wi-Fi off, and hers is downloaded immediately. Mine downloaded in about 2 minutes, but it was on the upper floor. If you would like to, this is not required. It's an exercise that we'll be doing today with you with Copilot. And I think it's good just to practice. And I think you are creative, ladies and gentlemen, and you're going to take this back to your institutions and figure out lots of different things that AI and something like Copilot can help you with.
Thanks, Tammy.
Great.
Thanks, Tammy. So I wanted to say just two things. Kelly Aldrich set up really well. Everyone who saw Kelly this morning is that we all have a seat at the table. And if we have a seat at the table, it's really important that we know what questions to ask. So hopefully you'll come out of this today with some questions to ask when you get that seat at the table when you're talking about artificial intelligence at your organizations. The other thing I'll say as a disclaimer, Tammy and I are not as funny as the two doctors that covered cybersecurity today. We don't do any of that stuff because we're nurses and we're hashtag GSD, get shit done. So that's just kind of how we are. All right. So we have a lot of content. Yeah, a lot of content in a short period of time. I'm just going to cover over a little bit on AI. It's not new. It's been around since the 1950s. In the 1950s, there were some really super smart physicists who decided to get together for 2 months at Dartmouth and say this thing called artificial intelligence. They actually named it artificial intelligence. And then in the 1990s, this thing came out called machine learning. I'm sure by now everyone's heard about machine learning. Machine learning is really all about how do we have, if-then statements, and how do we essentially use a lot of data to train, right, to train a model, and how do we leverage it. And you're using machine learning today in anything you do with predictive modeling, scoring, et cetera. And then in 2017, deep learning came out. Deep learning is really, these deep neural networks that have come into being. It's really complexities of machine learning. And the reason why we're talking about what we're talking about today is more around AI and generative AI. That came out last year, so maybe 2 years ago by now. I think it was a year and 8 months maybe. The difference in generative AI from everything else is really how it democratized artificial intelligence. I can write a prompt and I can get information. I can summarize large documents, et cetera. I don't need to be a physicist to be able to do it. So that's the difference. And that's why we're talking about it now. And that's why it's important to all of us. So this is just a quick definition of AI that we'll use for today. An area of computer science that emphasizes the creation of machines that work and react like humans, okay? It's not taken over. This means a system that can depict or mimic human brain function, including learning, speech, recognition and generation, problem solving, vision, and knowledge generation. So just so we kind of have a level playing field on AI and what we're talking about with AI. So machine learning, as I mentioned, there's things like machine learning, deep neural networks, and we have other key concepts around AI. So we'll cover them briefly, and then intermittently we're going to stop today, and we're going to have you launch your, if you choose either ChatGPT or Copilot, which is that if you've been able to download it. We'll give you one more opportunity to download it if you choose to do. So machine learning, as I mentioned, is really around the algorithms and statistical models that are enabled for computers essentially to learn from data without being explicitly programmed, right? So there's a lot you can do with machine learning. And there's opportunities also to leverage deep learning, which is really the type of machine learning that uses those deep neural networks that I mentioned. And then they're really kind of a set of algorithms that are modeled around the human brain, so they can recognize patterns, so they can analyze really, really large amounts of data. So this is what the difference, right? It's billions of data elements, and that's why generative AI, one of the big things about generative AI is just the amount of data that it looks at. Then you can look at AI into a few classifications from narrow or weak to general AI, strong or super intelligent AI. Narrow is really very specific tasks that are performed. General AI can be more learn and perform those tasks as a human can do. And then super intelligent, it's hypothetical. We haven't gotten there. And you may hear a term called artificial general intelligence. Some super smart people also use that term because they think eventually it'll be that smart. We just haven't gotten there yet. So remember, the important thing is that you're not going to know all the answers after today, but you will know maybe what questions to ask if you're in these conversations, either with your leadership team or with the developer on your team or whoever you work with around AI. So the large language models really are generating text word by word, and they have an end token that they generate. They rerun it every time they have a token. So it's going to run through, and then it's going to start again. It's going to run through. It's going to start again. And that's what's really important because you need a lot of compute power to be able to do that. These are essentially foundational models. And then they can become autoregressive, so kind of move forward. They generate the token, again, that you guys can come in. You don't have to be shy. Sorry. And there's people standing. You don't need to. There's actually empty seats up here in the front. So remember that that when you look at text generation, it can auto-generate, and then it'll kind of go through, it'll auto-generate again and again. So it kind of goes back through this pattern of behavior. But again, it's going through it with just tremendous amounts of data, huge amount of data. Large language models are really very versatile. They're very powerful tools that we have that can look at any language. They have a wide variety of applications. They can do content creation. They can do summarization. They can do service automation. So it's really all around that automation of processes. They can be trained to understand. They can be trained to generate and interact with natural language. Remember when I said some really super smart physicists started about AI in the 50s because they had to be physicists, and then you had to kind of be a mathematician. Well, now I can essentially use natural language, be able to generate information from a large language model, and that's the power of it. Like I said before, we democratize this ability to work with these large language models. So they use huge data sets, tremendous amount of volume of data. And so as you're hitting, when we look at Copilot or you look at ChatGPT, you can use either one. The back end of that is just a tremendous amount of data that it's been trained on, and we'll talk through a little bit of how you're getting those answers.
Before we talk about, oh, sorry.
That's
I
okay.
interrupted you.
That's okay. That's all right. I kind of covered some of these already, but just to give you an idea, some of the definitions that we're kind of working with is that the large language model is really the type of AI that generates those patterns and the relationships. And then the tokens are really essentially looking at how they're predicting that context. Tokens are a single instance of the data in the model. There's things that are called token limits or context limits, and you'll see that there's some rules around how many tokens can be generated, and I'm going to talk about tokens a little bit more and exactly what a token is. Embedding is really just a vector representation of the data and how it's been tokenized. Embeddings really represent all the vocabulary or all the tokens that the large language model can output. And then we do have this concept of hallucination that I added in here, and that's kind of when the model will make things up, and we're going to talk about confabulation as well.